All right, so we're going to look at inequalities here. So first, we're going to just do a little practice interpreting a statement and writing the inequality that represents that statement. So the first one is, in order to ride on a roller coaster, your height must be at least 52 inches. So we'll say height has to be bigger than or equal to 52 because it's at least 52 inches. Before 2013, a person in China must have under 2 children. So children will be represented as C. So C has to be less than 2. So you heard that correctly. Before 2013, you were allowed to only have 1 child in China. 2 is not okay. That's why C is less than 2. And we said under 2 children. And of course, you can't have half a child. So you were only allowed to have 0 or 1 children before 2013. The government has since kind of relaxed the one-child policy. Part C, the amount of money M that Sandra can spend on concert tickets is no more than $150. So that means the money that she spends can be less than or equal to $150 because no more than. So no more than implies that equal to is okay. All right. Now we're going to look at how we graph inequalities and how we solve inequalities and how we graph the solution. So we solve them just like we solve equations. We look at the inequality symbol as kind of being the middle of the equation. So we've got a left side and a right side of that sign. So I put that dashed line to divide sides. It's all the same stuff that we did with solving equations, except for one minor detail. When you multiply or divide by a negative number, you must flip the inequality. All right, so if I subtract 5 off of both sides, I get 2x is bigger than 45. Now, subtracting 5 is okay because I didn't multiply or divide. So the inequality stays facing in the same direction. I divide by 2. So I get x is bigger than 22.5. Now, I did divide here, but I divided by a positive 2. Right? On both sides of the inequality, I divided by a positive 2. So I do not flip the inequality because it was positive. So my solution is all x values bigger than 22.5. So now if I want to graph that solution, maybe I go 20, 21, 22, 23, 24, 25. Okay, I just wrote those backwards. That's fun. So 22.5 is somewhere right in the middle between 22 and 23. I use an open circle because I don't want to include 22.5 in my solution set. If I plug 22.5 into the statement, I get 22.5 is bigger than 22.5. That is false. So I don't want to include that in my solution. What I do want to include is all the numbers bigger than 22.5. So I draw an arrow facing this way because those are all the numbers bigger than 22.5. All of those values are in my solution set. So I can pick any number off of that shaded part. Let me say I'll pick 24.2. If I plug in a 24.2 for x, I get a true statement. 24.2 is larger than 22.5. Conversely, I'll do this in purple. If I pick a number on the left side there, or a number that's not graphed in the solution set. So remember, this is not in the solution set 21. If I plug it in into my statement, I get 21 is larger than 22.5. That is a false statement. That's why it's not shaded. It's not a solution. So now over here we ask a follow-up question. Is 23 a solution to the inequality? Explain or show your work. So my inequality was x is less than 22.5. And there's a couple ways to look at that. So if I want to show my work, I can plug 23 into the statement and analyze. Is it true or is it false? 23 is larger than 22.5. That is a true statement. So then 23 is a solution, and your explanation can be it makes the inequality statement true. Another way to do it is to look at the solution set that's graphed. 23 lies here on the graph side of the solution set. It is colored in by the line. Therefore, 23 is a solution. So you could say 23 is graphed on the solution set. Therefore, it is a solution to the inequality. Let's look at another one. To solve this inequality, x appears only on the right side of the equation, so that's good. So I'm going to start by getting rid of that plus 5. Remember, that's a plus 5. So I'm going to subtract 5 off both sides. So I'm left with negative 3x on the right side. And on the left side, I get negative 9. So now I don't have to flip the inequality, notice, because all I did was subtract 5. We only flip the inequality when I multiply or divide by a negative number. In the next step, I've got to get rid of the times negative 3. So I'm going to divide by negative 3 on both sides. So over here, the negative 3 divided by negative 3 is 1x. Notice I flipped the inequality because I have divided by a negative number here on both sides. So now the inequality flips, and I get negative 9 divided by negative 3 is just a positive 3. I like to also write our inequalities with the variable written first. You should always read them variable first, no matter how it's written. So this inequality, this one here, I don't read it as 3 is larger than or equal to x. When we read it, we should always read from the variable over. So we would say x, we would read this way. We would actually read this right to left. X is less than or equal to 3. And if I read it over here, if I start at the variable, this time I'd be reading left to right. X is less than or equal to 3. Either way, I would read that because it's a little easier to understand. X means all the numbers. So I would say like all the numbers less than or equal to 3. So if I were to graph this solution, it would be 3 would be included because it's less than or equal to, and all the x values less than that mean if I go to the left side. Okay? Is negative 3 a solution to the inequality? Yes, because negative 3 is graphed on the solution set, or in the solution set. All right, negative 3 is on the graphed side of my solution set. Or you could plug it in to the inequality. You could say negative 3 is less than or equal to 3. That's a true statement. So it satisfies the inequality. All right. That's good.